right, example 7. A low orbit satellite orbits the Earth at an altitude of 200 kilometers with an orbital period of 90 minutes. What is the orbital speed of the satellite? And then we'll add at the end. The Earth has a radius of 6,371 kilometers. Okay, so low orbit satellites. Does anyone know what low orbit satellite is?
Yeah, orbit's pretty low.
It orbits low, right?
It's not way out there.
It's not way out there. Good. Low orbiting satellites, like the Hubble Space Telescope, is not a low orbit satellite. That's a high orbit satellite. Okay. A low orbit satellite is like the Verizon satellite that gives your cell phone signal. Okay. Or the DirecTV satellite now that gives your TV, DirecTV, or Dish Network, whatever you choose. You can turn it on. It's fine. All right. So, if this is my low orbit satellite, actually the dish wouldn't be facing that way. That doesn't make sense. The dish would be facing that way towards the Earth. Okay. So there's my low orbit satellite, right? Okay. Amani, orbit means it goes around the Earth, right?
Yep.
Now it tells us that the orbital period is how much? The orbital period is how much?
90.
90 minutes. So that means every 90 minutes this satellite goes around the Earth once. Okay? That's kind of fast. So T equals 90 minutes. Can I keep this in 90 minutes?
No.
No, we have to switch it to
Second.
seconds. So to switch that to seconds, we multiply by what, Skylar?
400.
60. And what do you get?
5,400.
Okay. So every 5,400 seconds, that satellite goes around the Earth, right? Does that make sense? Okay, pretty fast. Any questions about that? Okay. Now, this right here is the Earth. I know it's very good artistic rendition. This is not to scale. Catholic C. Okay. The Earth has a radius of what?
6,371.
Okay. Kilometers, right?
Yep.
The satellite is how far above the Earth's surface? 200 kilometers, right? So, what is the radius of the satellite's circle?
6,571 kilometers.
Good, 6,571 kilometers. So this whole blue line right here, that is the radius, right? So the radius is equal to 6,371 plus 200, right? Which is 6,571. Now, the reason why I'm going through a period conversion and a radius addition is because when I give a problem like this to a student, they will often work with a radius of, what do you think? 200. They'll pick 200 as the radius. Okay? Because they say, oh, that's how far it is above the Earth. That's how big the circle is. It's the radius, 200. Okay? That is how far it's above the Earth, right? But if I'm thinking about the whole radius of the orbit, we have to include the radius of the Earth as well. Okay? And then, what do you think they'd use for the period? They'd use 90, right? Because students don't often want to convert. Now, in order to do this problem successfully, we must convert minutes to seconds. We have to add these two radiuses, right? And what's the last thing we have to do?
Do you have to convert to meters?
Good, we have to convert this to meters, right? Now this kilo, means times 10 to the third. So I can just rewrite this as 6,571 times 10 to the third meters. Okay? Does that make sense? Yeah. So now I have lots of information. Time is 90 minutes, 5,400 seconds. Radius is 651 kilometers, which is 6,571 times 10 to the third meters. Okay. Now we want to figure out the velocity of this satellite, right? Right? The velocity this satellite has the whole time it goes around in the circle. Right? That's what we want to figure out. So, what equation should I use?
Number 1.
Number 1. Okay? That's V equals 2 pi r over big T, right?
Is this only two equations we're going to get this one?
Nope. Okay. So, now I can plug in what I know. So, V equals 2 pi times the radius, 6,571 times 10 to the third, over the period, 5,400.
Yeah, that's what
Okay. Notice, one second, Skylar. Notice I'm using times 10 to the third because it has to be meters, and 5,400 because it has to be in seconds. Okay. So I'd like you guys to try to calculate that. Okay, good. Don't shout it out.
So you go with
When you're plugging your calculator, hit 2 pi times 6571 e
Yeah.
3
It's the little pie.
divide 5400.
It's the arrow.
Now in this case, if you use times 10 to the third, you won't get the right answer. If you use times 10 exponent 3, you'll get the right answer. Try to be helpful. Yeah. But if you were to divide, guys, if you were to divide by this number, so let's say you're doing some algebra, you're dividing by it. If you do not use e when you divide, it'll mess it all up. Okay, so that's why I want you to get in the habit of using e. Okay. E is what your calculator, it means times 10 to the third. Okay. Hit second comma. I know, like I just said. If this time, if you didn't use e, it probably worked, or it did work. Okay. But if let's say we were trying to solve for something else and we had to divide by this number, if you use times 10 caret 3, right? Then your calculator sees this as one number and times 10 caret 3 as a second number. So what the e does is it kind of puts parentheses around this and says this is one number to your calculator.
So what E would
Right.
we use? Just the
Second comma.
Oh, you just put.
Yeah.
Well, I couldn't even do that. You just put 0.
No, that's fine. So what do we get? What's the velocity?
Oh, 7, 6,
I got
7, 6, 4, 5,
7, 0, 5, 6, 7, 7.
Okay, 764.
5.70, 5, 6, 7.
That's close.
Okay,
7 1. Just put 7 1.
Okay. So that is our velocity. Okay, very fast or very slow?
Very fast.
Very fast. Lots of meters per second.
Not as fast as you should.
Any questions about that?